Alright class, so today we're going to talk about the 5 types of reactions. Because later on today we're going to be learning how to predict products based on the reactants. You'll need to know these 5 types of reactions in order to do that. So the first one is synthesis. And a synthesis reaction is where 2 or more simple compounds combine to form a more complicated one. So, in a synthesis reaction, you'll have the general formula A plus B turns into AB. And so an example of that would be like Mg plus O2 turns into MgO. Now you'll notice that because Mg has a 2 plus charge and oxygen OS has a 2 minus charge, they bond together very nicely here. 2 plus is cancelled out by the 2 minus. So there's no need for subscripts. It's just MgO. Now, in order to balance that, I notice that I have 2 oxygens here and 1 oxygen there. So I'll put a 2 out front. And now I have 2 magnesiums. Only 1 magnesium here, so I'll put a 2 out front here. Alright, there are 4 analogies for these reactions. The first type, a synthesis reaction, it's like a relationship. You first start dating. So, Mg and O got together and started dating MgO. Don't worry, they get even better as we go. You'll get to see a demonstration of magnesium oxide right now. So go ahead and pause the video, and Zoe will burn magnesium in the presence of oxygen to show you that reaction. So, you guys have just seen magnesium oxide burn in air. We did this lab, but you burnt your magnesium in a crucible and waited to see if you had that white fluffy substance. Your crucible got heavier because your magnesium and your oxygen combined to a heavier substance. Alright, that is a synthesis reaction. The next reaction is a decomposition reaction. A decomposition reaction is where a complex molecule breaks down to make simpler molecules. So, the generic form of that is AB turns into A plus B. A general formula is AB turns into A plus B. A specific example would be water. When water breaks down through electrolysis, so you run electricity through it, water will turn into hydrogen gas and oxygen gas. So H2 and O2. And that is a decomposition reaction. You guys, later on, will need to be able to look at this and say, oh, this is a complex molecule, breaking it down into 2 simpler ones, and be able to identify this as a decomposition reaction. The analogy for a decomposition reaction is a breakup. You can pause here if people need a little more time, otherwise we're going to move on to the next 2 examples. The next 2 we have are single displacement and double displacement. So a single displacement reaction is where one element trades places with another element in a compound. The general formula is A plus BC turns into AC plus B. And the example we have is magnesium plus hydrochloric acid turns into magnesium chloride plus hydrogen gas. Alright, but this is incomplete because if you look at it, magnesium has a 2 plus charge. and hydrogen has a plus charge, and chlorine has a negative charge. So here, our magnesium still has a 2 plus charge, but our chlorine has only a negative 1 charge. So in order to balance the charges, we actually need 2 chlorines. And then if you look at our hydrogen, hydrogen is one of the naturally occurring diatomic elements, so we actually need 2 hydrogens in order for this reaction to take place. Go ahead and pause the video as Zoe demonstrates this single displacement reaction. Alright, so now that you've seen that magnesium get dropped into hydrochloric acid, you witnessed one of the ways you can know that a chemical reaction has occurred. You saw bubbles, and if you were able to touch the test tube, it was hot because heat evolved from it. If you weren't able to touch it, that's fine. Trust me, it was warm. So you've seen heat and bubbles. Now we're going to talk about a double displacement reaction. Oh, sorry. Yes, this is the analogy. The analogy for this, we've got a cheater on our hands. Mg came in and kicked hydrogen to the curb, and it became MgCl and hydrogen all on its own. Alright, so the next thing we have is a double displacement reaction. A double displacement reaction is when the anions and cations of 2 different molecules switch places, forming 2 entirely different compounds. You can go ahead and pause this for a second as everyone writes that down. Alright, so the generic form is AB plus CD turns into AD plus CB. You can see that our A and our C have switched places. A is now with D and C is now with B. So that is the double displacement. You can think of it like this. A was our positive cation, B was our negative anion, C was a positive cation, and D was a negative anion. Positives always want to be bonded to negatives. But if these guys are going to switch places, A must be bonded with D because it's negative, and C, which is positive, must be bonded with B. So, that is our generic equation. The example that you guys are going to get to see is lead nitrate, lead 2 nitrate, plus potassium iodide turns into lead iodide and potassium nitrate. You can pause this video as Zoe does this final demonstration. Alright, so what you've just seen is Zoe added clear lead nitrate to a beaker of potassium iodide. Now hopefully what you saw was a bright yellow precipitate form. So the precipitate was lead iodide. Lead iodide isn't soluble in water, so what happened was when that lead iodide formed, it became a solid instantly and started to float to the bottom. And our potassium nitrate is still just an invisible solution. It's actually just potassium ions and nitrate ions floating in there. But you've now witnessed the 2 other ways you can tell a chemical reaction has occurred. There was a color change and a precipitate formed. So that is our double displacement reaction. Last one we're going to talk about is a combustion reaction. So I'm going to get all this out and then talk about it a little bit. So go ahead and pause the video and give everyone a minute or 2 to write all of this down, and then I'm going to talk through it. Alright, so a combustion reaction is when oxygen combines with another compound to form water and carbon dioxide. So you will always have O2 turning into CO2 and H2O. The only thing that will change is this hydrocarbon. It will always have a carbon followed by a hydrogen and any number of carbons and hydrogens attached. So if it's C3H8 or C2H6 or C7H16, it doesn't matter. The rest of it, to tell you it's a combustion reaction, it will combine with O2. At that point in time, when any of these combine with O2, or anything that looks like them combines with O2, you automatically know water and CO2 are going to be the products. And from there, you just balance it by adding coefficients like we did for this top one. So that is a combustion reaction. Alright, what you guys are going to do right now is work on this worksheet 8.3, which you either have already or will be passed out to you right now. You want to work on the side that says 8.3 types of reactions. Problems 1 through 12, you'll be balancing the equation like you did before, but then on the far left-hand side in front of the number, you'll be writing S if it's synthesis, D if it's decomposition, SD for single displacement, DD for double displacement, and C for combustion. If you have questions, I've provided a filled out answer sheet to the sub, but I'd like you to try these on your own, so form up into your families and work together. If you and your family get it, I'd like you to move around to other people in the class who are having a little trouble. So today is going to be a big day for you guys helping each other out. Don't be shy to help one another. Don't be shy to ask for help from one another. Alright, good luck guys. Talk to you again in a few minutes because we've got one more video to do.